Welcome everyone to the CCPO-ICAR seminar series today, March 11th. And I want to thank our seminar speaker, Dr. Allison Reilly, for joining us today for her presentation on infrastructure reliability and the burden of sea level rise. Do current planning metrics capture the correct risk? Dr. Reilly is an associate professor at the University of Maryland in the Department of Civil and Environmental Engineering in the area of risk and infrastructure systems. Her research focuses on unpacking the dynamics between policy and infrastructure vulnerability, and she has worked on problems in numerous infrastructure sectors, including electric power, water distribution systems, septic systems, transportation systems, and cybersecurity. Her recent work has focused on risk equity within rural coastal areas vulnerable to sea level rise, and related to that, how investments in infrastructure that are integrated within broader resilience strategies may enable more just transitions. Welcome, Dr. Reilly, and I look forward to the presentation.
Hey, thanks so much, Hey, and thank you everyone so much for having me today. So yes, I'm Allison Reilly. I'm an associate professor at the University of Maryland in the Department of Civil and Environmental Engineering. My work, I'm really interested at the intersection of hazards, infrastructure, and people, and how these three areas converge to create risk. So as I go through my work today, I'll be presenting mostly on work that we've done on transportation, some work on on-site septic and sewer. But if you have questions, I'm happy to answer brief questions throughout my presentation, though I will admit on Zoom, I might not always see them. So especially given it's a few participants, please just unmute yourself and I'm happy to answer any questions that you might have. And obviously at the end, I'll reserve some time to have a more in-depth discussion as well, okay? I'll just get started then. Okay, let me just close this meeting panel so I can just see my slides fully. Hide video panel, okay. And hide vote meeting control. So you can still see my slides?
Yes.
Yeah, go with yes. Great, thank you. Okay, so this is going to be no surprise to anyone in the audience today, but sea level rise is expected to inundate numerous homes across the coastal US. So by 2100, the Zillow study, which many people are probably aware of or familiar with, is expected to inundate more than 1 million homes by 2100. And obviously there are confidence intervals and uncertainty within this, but the takeaway is that a large number of homes are expected to be inundated by sea level rise over the next century, with not unexpectedly Florida, which has significant exposure, having the most, but in the areas that I work within Maryland, expected to have about 65,000 homes inundated, and in Virginia, 46,000 homes. So just to try to give you a scale of the problem. And there's been a number of studies looking at really zooming in on different areas and really trying to understand household inundation and who is going to be affected and what are the demographics of people who will be affected by household inundation. So a study by NOAA really looking at housing in 2022 looked at 4 major cities: Atlantic City, Miami, Galveston, and Newport, and found a range of possible outcomes by 2100. In Atlantic City, about 3,000 properties by 2100, but it could go up to 12,000 homes under high-risk sea level rise scenarios. So it's not only, as you well know, the household or the house itself, the home that is at risk of sea level rise, but the people who live in that home who are at risk of sea level rise and will force displacement ultimately of those individuals. This is work by Matt Howard, 2016, and there's follow-up work that he did in 2018 of looking at where will displacement be caused due to parcel or household level inundation, and what is the spatial extent across the United States for using different sea level rise scenarios. So in the can you see my mouse?
Yes.
Perfect. Okay, that makes it a little bit easier. So in the orange, this is about a 1 meter sea level rise by 2100, pretty low risk outcomes. We expect about 3 million people being forced to being displaced by sea level rise, looking at all the coastal counties in the US, with a much more aggressive sea level rise scenario with 1.8 meters by 2100. We see upwards of 13 million people affected and forced to displace by sea level rise due to household inundation. And this is not only a US problem, not surprisingly, this is an inundation, this is a global international problem. And so work has looked at what does this look like internationally? Which countries, which nations, areas will be affected by sea level rise? And they've always measured it by when will one's home flood? And looking at using a 2 meter sea level rise scenario by 2100, globally, worldwide, 187 million people globally will be exposed to sea level rise. Here's the United States and Canada. It's a proportion to other places in the world. It's almost a little blip, especially relative to the Asian Indian Ocean and Southeast Asia. And when we look at metrics used from housing and parcel inundation, these are really common for understanding climate migration and are the key metrics used in climate adaptation planning. So if we look at the climate adaptation literature, and these really rely on these metrics on household inundation. When will people be forced to displace due to a house being inundated? And some guidance and planning documents developed by nations and US states have used housing as their primary or sole criterion for looking at adaptation planning. For example, New Zealand, which has really great comprehensive planning for sea level rise and climate change, really relies on housing as this metric. And even the state of Maryland, which I'm involved in some guidance setting for adaptation planning, we're really looking at housing in Maryland. And it's not unreasonable, I think, to look at this approach of when houses will be inundated. It's reasonable, it's defensible, it's also reproducible. It's easy to explain to individuals about how adaptation or why retreat will be forced to occur at that point in time. However, I would argue, especially as a civil engineer, that sea level rise will have widespread effects on infrastructure beyond housing. So we know sea level rise is not going to just affect housing, it's going to affect roads, it's going to affect schools, it's going to affect emergency management, wastewater systems, water systems, power systems, and so on. And we have to think not about only when will houses be affected, but also when will those other infrastructures be affected by sea level rise, and what does that mean for the provision of service, the provision of that infrastructure service to individuals. And it's that latter part, is that provision of service, that is really hardly understood at the intersection of sea level rise and infrastructure. And so that's what I'm going to actually be talking a good deal about today's presentation on, is that provision of mostly transportation services, but also some on-site septic. And it's also not always clear when and how the loss of residential infrastructure, so like on-site septic or loss of transportation access, which we'll talk a lot about, will begin to burden communities and cause retreat. We're going to talk a little bit about that later. But this is also highlighting the importance of really involving social scientists and communities outside of civil engineering to understand really when this loss of the provision of infrastructure services really starts to burden communities and individuals and how they're forced to adapt. And so what my research is, and we'll talk about here, is what do we miss when we plan for only parcel inundation? What else is out there? What other risks are we ignoring? And I want to also add, and we'll look at this later, that this burden is not always felt evenly. We know that marginalized communities are overexposed and have more challenge, more difficulty adapting due to fewer resources, less political power, and so on. And so we really have to understand not only what are we missing, but what is that the spatial and the social kind of implications and the distribution of this burden. Okay, so the remainder of my talk, I'll be looking at sea level rise and isolation in Maryland and the United States. So isolation, I'll define later, but it's really loss of access to essential services. And then I'll also talk about some work we have going on with the effects of sea level rise and rural wastewater treatment. So just some background on Maryland. I'm sure none of this will come as a surprise to most folks in the audience today, being so close to Virginia, but similar to Virginia, Maryland is a tableau for the burdens of sea level rise. It's the second fastest sea level rise in Maryland. Is the second fastest in the nation. I think that's only second to Virginia. So sorry that you have that honor. And in Maryland, there is 7,700 miles of coastline. So it's a very fractal coastline in the state. The area that I really do a lot of my research for sea level rise is on the eastern shore of Maryland. So over here on the eastern shore, there's a lot of cultural and historical significance to this area, despite being so rural. This is the area where the Underground Railroad began. Harriet Tubman National Park is right over here. And also the land has been sinking and the waters have been rising in this area for a very long time. Over 100 years ago was the first instance of collective retreat in the state of Maryland. And so this has been an ongoing problem for quite some time of flooding in this area. It's not a new problem, but I will add that the rate of sea level rise and the problems that it's causing has accelerated drastically in recent years. Okay, so what has this meant? What has sea level rise meant for these coastal residents? So we hear a lot of anecdotes, and anecdotes, plural of anecdotes are not data, but we're learning. But it has forced adaptation for many coastal residents and the workforce. We've heard reports of people purchasing larger vehicles so they can make sure they can get to work. We've heard reports of the work of certain jobs having shifts that reflect the tides to make sure that people can get to work and get to work safely and get home. So you report to work at low tides. We also, in the state of Maryland, school, if you can't safely get to a school due to road flooding, it's also an excused absence at school. And currently the state of Maryland is actively producing laws and guidance related to sea level rise. You're not supposed to use, it's challenging to use state funds to develop in areas vulnerable to sea level rise. It's not impossible, but there's rules impeding that. There's also a guidance document now that was produced, I was part of how to build and mitigate in areas vulnerable to sea level rise, to thinking specifically for infrastructure. The state is currently seeking help and for planning for sea level rise, and it's specifically for asset retirement, which is really code for where are we going to abandon assets, state assets, and what will this mean for individuals. And also there's questions about what risks we are not capturing here. So historically, there's been surprisingly little research about how sea level rise will affect roadways and mobility. Jacobs et al. 2018 did a really interesting paper looking at roadway tidal flooding and roadway flooding found 7,500 miles along the East Coast is vulnerable to tidal flooding. That equates to about 160 million vehicle hours of delay annually in 2020. There have been a few studies looking at urban centers and the response time of emergency vehicles and congestion due to flooding. But overall, there's really little work that's been evaluates not only what is being flooded, but also who is being affected by roadway flooding, and what does that mean for an individual. Okay, so what I'll talk about now is some work that we've done on loss of access to key amenities. So the research questions that we've posed here are: how many people are at risk of losing access and risk of being inundated due to sea level rise? So by loss of access, I'll go in depth in just a moment, but it's really who is unable to get from their origin or their house to some key destination. Also, another question that we've looked at is: what is the spatial distribution of people losing access? And how does this compare with the spatial distribution of people at risk of inundation? So the houses that are vulnerable to inundation could be very low lying, but the houses that are people who live in homes that are high up on a hill still could be vulnerable to not being able to access key amenities because the roadways in which they rely on are flooded, and there's no alternative routes available that are unflooded for them. We also want to look at the spatial and the temporal differences between the onset of losing access to key amenities and the onset of inundation. And that temporal difference is really what we argue is that difference between what are we planning for with inundation, right here, this onset of inundation, this is what we're planning for, but could some of these burdens of sea level rise happening long before this state that we're planning for with inundation? And also, we've done some work looking at this isolation risk and how it varies amongst different racial and ethnic groups across the coastal areas of the US. So I'll present one study that we did at Dorchester County. Dorchester County is in Maryland. And it is currently the second largest county in the state of Maryland geographically by size. And by 2100, it is expected to be the 19th largest county by size. So it's expected to shrink by over 60% in land mass. So massive loss of land in this county. And I'll also show some work and results from another study looking at all coastal counties in the United States. So loss of access, and why is this a relevant measure of burden? So accessibility is the ability to travel or access a destination. A lack of access, so there's a lot of work I should add on accessibility in more urban areas. So you've probably heard of food deserts. What is someone's ability to access a grocery store in an urban environment? We know from the literature, especially in urban environments, that a lack of accessibility reduces economic and social opportunities. It hinders people from getting jobs and maintaining employment. It makes it difficult for children to go to school and stay in the lack of access to schools, especially due to flooding, means more missed school days. Also, a concern in the eastern shore of Maryland with lack of accessibility, especially due to flooding, is a lack of ability to participate in civic events and voting. There's also reduced ability to receive urgent medical care and other emergency services. I have heard anecdotally from two people that I know who live on the eastern shore of Maryland is that they decided to move and relocate. They sold their home because they were concerned about being able to access medical care and get to a hospital as they age in place due to flooding. It also makes we know from the literature, especially in urban environments, a lack of access makes regions less desirable and can suppress property values, tax rates, etc. But this work making the desirability of a location has not really been explored within more rural environments or due to sea level rise. Also, a lack of access, which is also not usually discussed, so lack of access that is caused by flooding makes co-located horizontal infrastructure less reliable. So that means like electric power becomes less reliable. Water systems that are delivered via pipe are more prone to cracking due to that wet infrastructure, and then also roadways themselves. Okay, so in both studies, what we did is for several sea level rise scenarios, we evaluated either parcel level or block level. For the study that looked at the entire United States, we looked at the accessibility to the closest grocery store, fire station, and school. And we actually also looked at change in travel distance. We overlaid all of these relative sea level rises, all of the relative sea level rise scenarios with the current road networks now. So we don't forecast where road networks will be in the future. And we also look at, as I mentioned there, relative sea level rise over the United States. So even if we expect, say, 2 meters of absolute sea level rise by 2100, we wouldn't expect that to be uniform across the United States. So we did downscale it to make it relative sea level rise based on tidal gauges and change in tidal gauge over time. And just to note, so if access exists, it might not be the closest amenity by Euclidean distance. So if you're trying to get to your a grocery store, a parcel may be not able to get to their closest grocery store, but it is possible that they could travel further, reroute, which is essentially a form of adaptation to a grocery store that is further. We would argue in that instance, they certainly do still have access, but they have to travel longer, so the access is poorer. Now we note, I'll just note for a moment, and I'll explain the importance of why I note this in a moment. In the Dorchester County study, we assume that cars can traverse 15 centimeters of water and trucks can traverse 25 centimeters of water. And this reflects the safety studies that cars can traverse 15 centimeters, or the upper limit of safe driving is 15 centimeters of water. Anything above 15 centimeters of water, cars really should not drive through. However, in later studies, we actually assumed anything greater than 0 is considered flooding, a road flooding. We know from anecdotally and just by science, repetitive exposure to salt water damages cars. We see that in Dorchester County with emergency vehicles. There's extensive corrosion under the belly of emergency vehicles due to corrosion exposure to salt water. So in future and later work, we did assume 0 centimeters of salt of water. And interestingly, speaking with geotechnical engineers about our work, they said, well, no, 0 isn't even appropriate. It should be less than 0, because as soon as you have any level of sea level rise, it really threatens the subsurface of the structure, of the road structure. And that even less water can really start to affect the roads and the reliability and safety of those roads. So I think, which is all to say, there's a lot of uncertainty about what is even appropriate for when the impacts will occur. And there's a lot of unanswered questions. So this is things I've mentioned before about Dorchester County, just especially how there's going to be massive amounts of sea level rise expected in this area. And I should say transportation divestment is occurring in this county. There are roads that have been identified and are no longer maintained because of sea level rise. So this is just the network, the road network in purple of Dorchester County. The blue, the aqua buildings are all fire stations. And this is roadway flooding in 2080. I'm sorry, the red is roadway flooding in 2080. And every 8 for RCP 4.5, I believe 17% exceedance probability. So just to add, in the state of Maryland, every 5 years, the state puts out a report on sea level rise projections. And so all of this work here are 2018 sea level rise projections. The 2023 sea level rise projections either just came out last week or about to come out. I just haven't been paying attention closely enough, but I know that they are just about to come out for 2023. So what they do is they say in 2023, or excuse me, 2030, 2050, what the projected sea level rise will be for different exceedance probabilities for the relative sea level rise. So the 1% probability of exceedance is just, there's a 1% chance it is worse than X. So in 2030, it's 0.4. The 5% probability of exceedance means there's a 5% chance it's worse than 0.34. And then we also have this likely range. This is the middle 66% exceedance probability. So Maryland has done this not only for 2030, 2050, but for two different RCPs, RCP 4.5 and 8.5. 4.5 is effectively Paris, holding to Paris, and RCP is unabated emissions. And then also for different exceedance probabilities. So I will add that I show most of the work through at the 17% exceedance probability. The state guidance for average infrastructure is to plan for 17% exceedance probability, and extremely critical infrastructure like power substations at the 1% chance of exceeding. Okay, and so this is baseline distribution. So no relative sea level rise. Again, here's the fire stations in aqua, the grocery stores in purple, the schools in blue, and each dot is a parcel. And we just map here, how long does it take for an individual in a parcel to get to their local grocery store, fire station, and school. And this is the cumulative distribution of access. But then we look at, okay, so, excuse me. Let me just go back to the right slide. Again, for Dorchester County and accessibility loss. So again, this is the 17% exceedance probability for relative sea level rise. We want to know how much further will people have to travel to get to their destination as a result of sea level rise, and who will start to lose access. So in 2030, not surprisingly, areas that are fairly remote, I think this is Hooperville, will start to lose access, and other areas here, you can see, will start to have to travel longer, about between 1 and 5 kilometers on average. By 2050, much larger swaths of the Dorchester is expected to have no access, and obviously then by 2080, under different RCPs, here this is RCP 4.5 and 8.5, far more households will lose access, and many more will have to travel longer distances in order to get to their destination. And so here is just the distribution of these spatial maps. But these, I should note, are not box plots, and there's a reason why I'm showing them, and I'll just explain in just a moment. So let's just take this box plot here. This is fire stations, and these are the results for 4 different years: 2030, 2050, 2080, and 2100. These are the results here. This is the red is the 1% exceedance probability, where we see about 8% of homes will lose access by 2030 to a fire station. And then with the 17% exceedance probability, it's about 4% of homes. Changing gear to 2080, then we have the 2 RCP scenarios, RCP 4.5 Paris. The 1% RCP is about 21%. RCP 8.5 exceedance of 1% is about 22%. So the reason I'm actually showing this is there's a lot of debate, at least in the state of Maryland and for other infrastructure systems, of what do we plan for? Are we going to plan for RCP 4.5 or are we going to plan for RCP 8.5? And there's usually a good reason of why that debate is. There's a ton of epistemic uncertainty about what will happen. Will we be able to abate carbon and comply with Paris? Or will we have unabated carbon and really just have terrible emissions and really extreme sea level rise and climate change? But the results here suggest, at least in Maryland, for access, the issue is really when we're doing planning is to really have consensus, not on which RCP that we're planning for, but really what exceedance probability are we interested in planning for? So what kind of risk tolerance can we assume kind of collectively? So if we're planning for, say, the 1%, they're almost the same for both RCPs, but there's starts to become difference. But you can see within these columns big differences between which exceedance probability we plan for. And one other thing about this study that I think is really important to highlight is that difference between when access will be lost and then when the parcel will be inundated. So remember that when we look at parcel inundation, that's usually the metric that we're planning for. But if people start to adapt and possibly even retreat in advance of parcel inundation, say due to accessibility loss, which we have seen more anecdotally, we might be planning for the right time. So here's a plot here. Again, every dot is a parcel, and all the red dots mean that when a house is inundated, meaning when the house is flooded due to sea level rise, it'll occur at the same time that they lose access to any grocery store, fire station, effectively anywhere. But any one that is not means there's a difference between when the parcel is inundated and when they will lose access. And we want to really look at that distribution. So 40% of homes will lose access at the same time they're inundated. But there's this tail of about 60% of homes that will lose access in years and years and sometimes decades before their household is inundated. So these parcels are probably missing when we're looking at adaptation planning based solely on parcel inundation. If we also, believe that accessibility and ability to get to a destination is also important and critical when deciding where one lives. In work that's under review, I won't get into too much depth about it, but we're looking at how and where roadway investments should go in order to maintain equity in terms of maintaining equity or maintaining access in an equitable way. There's a lot of talk in Maryland of how do we balance in this balanced approach, maintaining access in rural areas and urban areas, and we can distribute resources, which sounds like great, but not surprisingly, far fewer homes can be protected than when you really focus on protecting assets in more urban areas. This is Cambridge, the city of Cambridge right here, and focusing more resources on more urban areas such as Cambridge, the city of Cambridge, you can have more effectively bang for your buck. Okay, so I'm going to proceed into work that we've done on coastal US and accessibility loss versus inundation. So what we did was take the work that we did very much at the local level, or looking at Dorchester County, and it blew it up into the entire United States and looked at what people are at risk of losing access and at risk of sea level rise in the United States for all coastal counties, looking at the temporal difference between these two, and then also expanding it to look at what does this mean for amongst different racial and ethnic groups in different areas, who's exposed and who's overexposed. So we looked at it at the census block level due to computational reasons. So we looked at ability to travel from a centroid of a block to any fire station, school, or hospital for multiple relative sea level rise scenarios and compared it to parcel inundation. And so I'll just start with this. This is just looking at different sea level rises. So 1 meter, 1.5 meters of sea level rise. Let me go back. So with 1.5 meters of sea level rise, we would expect about 3 million people to have their homes be inundated, but we would expect, going up here, nearly double that at 6 million people to be isolated, meaning they're unable to get to any grocery store, school, or fire station. And we can look out to with up to 3 meters of sea level rise, which would be massive, admittedly. We then downscaled this to looking at different sea level rise scenarios. So intermediate low sea level rise scenario, which would be 0.5 meters of sea level rise by 2100, up to 2 meters of sea level rise by 2100. We can see that by 2080, the difference between the number of people who lose access or are completely isolated and the people who are inundated is about 500,000 people for a very low risk climate change scenario. But if we go project out to a really high sea level rise, 2 meters by 2100, the unabated carbon emissions, we would see that by 2080, the difference is closer to about 2 million people. So those would be 2 million people where we missed by using inundation metrics alone. We also looked at that spatial extent across the United States. So these are all the coastal counties, and we looked at the ratio of people who are at risk of isolation versus the risk of inundated. So, and black or dark purple is worse. Light purple is a lower rate. So what this is saying of areas like coastal Maine, parts of Northern California, there are a lot more people expected to be isolated relative to be inundated. So if they're using inundation metrics for their sea level rise planning, there's a lot of people that they're missing in their metrics in areas like Maine, parts of Virginia and Maryland and Northern California as well. Here we mapped it by state. Florida, not unexpectedly, is ranked the highest in terms of inundation. So we put that first, and we did it corresponding to risk in terms of cumulative exposure. Florida, the blue here, these blue lines are the number of people who are expected to be isolated, or the fraction of the population that is expected to be isolated under different sea level rise scenarios. So in Florida, with 3 meters of sea level rise, you'd expect close to 35% of the population to be isolated or unable to get to a grocery store, school, or fire station, and correspondingly only about 25% of the population would be inundated, have their homes flooded. So I will add that all of this data are available for viewing, and at the county level, I believe in most of Maryland, it's at the census tract level, and I'm happy to discuss with people afterwards if you want more specific data in some areas as well. So we also then used this data to look at how does isolation risk vary amongst different racial and ethnic groups. Communities with relatively higher social disadvantage, say racial minorities, older populations, renters, are more likely to be abandoned rather than protected. So meaning they will not, these areas are far less likely to receive, say, sea level wall protection and other hardening. They also tend to have reduced capacity to adapt due to limited resources. And this is also often aligned with this historical land use policies, less political power, less collective efficacy, and existing racial and social and economic disadvantage. And so we took this data of looking at who is isolated at the block group and compared it to so we looked at the fraction of the population at the block group who is expected to be isolated or lose access, and compared it to the population of the county, and to see if those disparities exist. And the disparity exists when the proportion of the group of the at-risk group is greater than the proportion of the group of the overall population. So there's like an overexposure. And up until about 4 meters of sea level rise, we see that white populations tend to be overexposed to sea level rise, and especially in terms of access, of not being able to access key amenities. This is primarily due to, we looked into the data, did some data investigation. These tend to be in many areas just more affluent areas that will lose access first, which is interesting, especially when if we expect that more affluent areas to experience more hardening and elevation of key roads. But as soon as we get beyond about 4 feet of sea level rise, we start to see that Hispanic populations at about 4 feet and Black populations about 5 feet start to be overexposed. So a greater fraction of their population is at risk than the population at large within that county. We then zoomed in to say 3 feet of sea level rise, and really zoomed in and looked at that at the county level. So this is where so we looked at 3 feet of sea level rise, looked at the county level, and looked at when will the Black population in the county, the Hispanic population of the county be overexposed, just simply be overexposed relative to the population of that within the county itself. We can see that there's a lot of overexposure at 3 feet of sea level rise in the Northeast and Mid-Atlantic, and then large parts of the West Coast and Louisiana as well. And then we also looked not only at the county level, but at the overexposure at the tract level. And so in the census tract level, so we compared the population at risk at the block level to the population and its demographics to the demographics of at the tract level. And so if we look at Black population for 3 different sea level rise scenarios, so 1 feet, 5 feet, and 10 feet, the overexposure is increased as sea level rise increases, and the same is true with Hispanic populations. So just to note that as I talked, there are a lot of unanswered questions that this research, I think, brings up that I think we really need to address in order to really understand what adaptation is and what are appropriate metrics for planning for sea level rise and climate change. So some of them, what does this lack of access mean? And the lack of other infrastructure services or lack of reliable power. What does that mean in terms of indirect costs? So what does that mean in terms of missed days of school? What does it mean for economic employment? What does it mean for whether or not people will stay where they are located or relocate? And also, how and will adaptation occur when provision of infrastructure services are lacking? So we know, so there's been some work in Crisfield, a really informal survey of trying to understand what adaptation has occurred and what is not occurring. We know from one recent very informal survey, it went out to about 20 or 30 individuals. They're averaging about $500 a year in car repairs due to saltwater corrosion of vehicles. So we know that there's some adaptation and some forced adaptation occurring, but we really don't understand what that looks like at a wider scale and what those costs are. We also don't know what roadway inundation means for road substructures. If there's geotechnical engineers out there, I really encourage you to think to address this problem. There's a little bit of work, right? Or there's some work, really good work, I should add, from the University of New Hampshire looking at this, but there's a tremendous amount of uncertainty in a lot of the mid-Atlantic states for what this means for road substructure. What does this lack of access and lack of other infrastructure services, so like reliable power, reliable internet, what does it mean for retreat and when will it occur and for whom? So will retreat happen sooner in wealthier populations, or will they stay longer because of more investment in wealthier areas that tends to happen? And then also who benefits and who is left behind when states and municipalities invest in limited protection. There's arguments that have been made in Maryland, and I'm guessing in other states as well, that in order to be able to fund and pay for roads and municipal services, they have to make sure that wealthier residents who have higher property taxes stay. And so we're really interested in who is benefiting from those type of perspectives. So given that I have about just a couple minutes left, I just want to just briefly talk about another study that we have going on also in rural Maryland on the Eastern Shore, looking at sea level rise in septic systems. So as I said, I'm an infrastructure nerd. I really am interested in what is provision of infrastructure services to individuals. And so we know, so in the United States, 20% of homes are on septic. And in Maryland, 52,000 homes are on septic and within 1,000 feet of tidal water. And there's this huge problem with salinity and relative sea level rise in terms of being able to remove pathogens. Flooding damages septic tanks. Communities of color are far more likely to be on septic due to how sewer expansion was done in the 1960s and 70s. And being denied communities of color being denied access. Septic systems can lead to public health emergencies and evictions. There are really tragic stories about lack of public health and septic systems and lack of hygiene in areas, and children being separated from their families until septic systems have been replaced. And we're looking right now into other technological solutions. So really in the state of Maryland, does this mean extending sewer lines, which is really expensive for taxpayers in areas that are vulnerable to sea level rise, or to invest and install raised septic systems, which are extremely expensive for homeowners? And what are other policy solutions that are available? So this work is really at the intersection of engineering and public health, sea level rise, and adaptation finance. Right now, my student is I have one student really looking at what is the reliability of septic tanks and forecasting failure. And interestingly, every state has different definition and of what a failed septic system is. And so some states, the rate of believe septic system failure is between 30 and 50%, say in Missouri, whereas other states, the rate of septic failures, like for example, in Arizona, where you define a failure much differently, is less than 1%. Maryland has defined what a failed septic system is, but that has not been translated into numbers, and we have no idea based on these numbers what fraction of systems in Maryland have failed. So just some takeaways from my talk today, and I'm happy to engage in more and answer any questions afterwards. But when we're looking at sea level rise, so planning and it says migration, but also mitigation studies have focused on coastal inundation and have really discounted the effect that unreliable infrastructure will have. So unreliable power, unreliable roads, as I presented here, and unreliable septic. U.S. adaptation policy at the state and federal level is incredibly sparse. And that which does exist really only considers household flooding and not infrastructure more broadly. And adaptation policy is really not well suited for these slow onset hazards, which is really challenging when planning for the Eastern Shore, where they're not expected to get large swaths of federal funding for climate change because they don't often experience major disasters where you have those large flows of disaster funds. So DOTs right now are considering which assets, what is their asset exposure and what are the relative divestment strategies, but they really don't understand at this point what are the implications of different divestment strategy, who is going to be affected and when, and what does that mean for the population, the community. And I think at the end of the day, climate change is happening, adaptation is happening, right? And so this is like the vehicle's moving. We got to get on, really understand because the time is ticking away. So, anyways, I really thank everyone for joining me today. Just a nod to my the funders of this research. So the National Science Foundation, National Academies, USGS, and the EPA have generously funded the work that I've presented today. And I want to thank everyone for their time